Good morning to all of you. Now I will tell you about colloidal state of matter. Thomson Graham studied the rate of diffusion of liquid and solution across the animal membrane, and as a result of his experiment, he divided the soluble substance into two classes, crystalloid and colloids. The substance like common salt, sugar, urea, etc., which can be obtained in the crystallization form and in the dissolved salt diffused through the vegetable and animal membrane were termed as crystalloid, and the substance like starch, gum, glue, etc., which are non-crystallization in nature and in the dissolved salt do not diffuse or have a little tendency to pass through the animal or vegetable membrane were given the name colloidal. Graham classification of substance into crystalloid were soon proved to be wrong. A crystalloid was found to be a colloidal under different set of conditions and vice versa. For example, sodium chloride behave as a crystalloid when dissolved in water, but behave as a colloid when dispersed in benzene. It has since that has been released that a clear-cut difference does not exist between crystalloid and colloids. The non-diffusion of colloidal and diffusion ability of crystalloids through the animal or vegetable membrane was shown to be different in size of particle of crystalloid and colloids. The colloids from the bigger particle which cannot pass through the membrane. It is therefore preferable to speak a substance in a colloidal state rather than calling in crystalloids and colloid. The particular size limited are given below. Size, diameter of particle. True solution less than the 10 raised to power minus 9 or 1 nanometer, or colloidal solution between 10 raised to power minus 9 and 10 raised to power minus 7 meter or 1 nanometer to 100 nanometer. Suspension more than 10 raised to power minus 7 meter or 100 meter. Thus, the size of colloidal particle it is intermediate between that of particle of true solution and those of suspension. A colloidal state of matter is therefore a state in which the size of particle is such 10 raised to power angstrom and 100,000 angstrom that they can pass through the filter paper but not through animal or vegetable membrane. Thus, every substance can brought into the colloidal state by adopting suitable method. The distinction between characteristic of true solution and colloidal solution suspension is given in a table. Characteristic of true solution, colloidal solution and suspension property. Particle size, fallibility, salting, visibility, diffusion, appreciance. True solution about less than 10 raised to power minus 9 meter or 1 nanometer pass through the ordinary filter paper as well as animal membrane. Do not settled particles are invisible, diffusion quickly and clear and transparent. Colloidal solution about between 10 is to power minus 9 to 10 is to power minus 7 meter or 1 nanometer to 100 nanometer pass through the ordinary filter paper but not through animal membrane. Do not shelter scattering of light by particle. It is observed under microscope. Diffuse slowly, translucent. More suspension about more than 10 is to power minus 7 meter or 100 nanometer. Do not pass through the filter paper and animal membrane. Settled on setting. Particles are visible to naked eye or under a microscope. Do not diffuse, opaque. A simple example to understand a true solution and a suspension and a colloidal solution is to consider the solution of sugar in water and that of water in which mud is stirred. This former is a true solution, but in case of later, so long as stirring is continued, the mud remaining is suspension, but as soon as stirring is stopped, The large particles fall to the bottom of the vessels. However, small particles remain in suspension for a long time, say for several days. This part of water containing mints and mud particles, which cannot be seen every under a microscope and pass through the filter paper, is a colloidal solution. Type of colloidal system. Just as in a true solution, the suspension dissolved in the is the called the solute and is medium in which it dissolve in called the solvent. Similarly, in a colloidal solution, the term solute and solvent are replaced by the term of disperse phase and dispersion medium respectively. Thus, the disperse phase mean substance distribute in the dispersion medium in form of colloidal particle, and dispersion medium means the medium in which substance disperse in form of colloidal particle. The colloidal system thus often is sometimes called colloidal dispersion or disperse system. Eventually colloidal system, but thus obtained in a colloidal dispersion or finally, unlike a two solution and which a homogeneous a colloidal system is heterogeneous, continue two phases, the disperse phase and the disperse medium, depending upon whether the disperse phase and the disperse medium are solid, liquid or gas. A type of colloidal system are possible: a gas mixed with another gas from a homogeneous mixture, which and not a colloidal system. The example of the various type of along their typical name are listed in a table. Type of colloidal system or colloidal dispersion. Disperse phase, dispersion medium. Name example. First, solid sols, some colored glasses. Second, solid liquid sol, some paints, mud, water. Third, solid gas, aerosol, smoke, dust. Fourth, liquid solid gel, cheese, butter, jellies. Fifth, liquid emulsion, milk, airy cream. Sixth, liquid gas, aerosol, fog, mist, cloud. Seventh, gas solid form, burning stone, form of rubber. 8. Gas liquid form. 4th, whispers cream. Out of the various of colloidal system list in table 7.2, the most common are solid in liquid, gel liquid in solid, and emulsion liquid in liquid. It must be mentioned that depending upon the dispersion medium, the sol are given special name as follow. Dispersion medium: name of sol, water, aquasol or hydrosol; alcohol, aquasol; benzene, benzosol; gases, aerosol. Classification of colloidal or colloidal sol. The various substances which form colloidal sol are divided into two categories, namely lyophilic and lyophobic. If water is dispersed medium, the term used hydrophilic or hydrophobic. Lyophilic colloidal. The word lyophilic means liquid loving. Substance like gum, gelatin, starch, rubber, etc., which when mixed with a suitable liquid as the dispersed medium directly from the colloidal sol are called lyophilic, and the sol thus obtained are called lyosol. As they form colloidal so directly, they are also called intrinsic colloidal, and an important characteristic of the sol is that disperse phase is separate from the dispersion medium. The sol can be made again by simple remixing with the dispersion medium. That is why these sol are also called reversible sol. Whether the sol are quite stable and cannot be easily precipitated. Lyophobic colloidal. The word lyophobic means liquid hating. Substance like metal, their sulfide, etc., which simple mixed with the dispersion medium do not form the colloidal sol. Their colloidal sols can be prepared only by special method or discussed later. Such substance or called lyophobic and the sol formed, they are lyophilic sol, and their colloidal sol has to be prepared indirect method. They are also called intrinsic colloidal. Their sol are readily precipitate or coagulate, and they are not stable. One precipitate, they do not give back to the colloidal sol by simple addition of dispersion medium. The sol are also called irreversible sol. The greatest stability of the Lyophilic colloidal salt, that the lyophobic colloidal salt is due to fact that the foramer are highly hydrated in the solution. The essential point of difference between lyophilic salt and lyophobic salt are given in table. 7.3 point of difference between lyophobic property, easy of preparation, stability, hydration, reversible and irreversible nature of substance, viscosity, surface tension, visibility, migration and electrical field. First, lyophilic salt. Prepared easily by direct mixing with the liquid dispersion medium. They are quite stable and are not easily precipitate and coagulate. They are highly hydrated. They are reversible in nature. One precipitate can reform colloidal salt by the simple remixing with the dispersion medium. These salts are usually formed by the organic substance like starch, gum, protein. Their viscosity is much higher than that of medium. Their surface tension is usually lower than that of dispersion medium. Their particles are neither visible or detected easily by the ultramicroscope by the scattering of the light. Their particles may migrate in the either direction or not migrate at all. Lyophobic salt cannot be prepared directly, prepared by the special method only. They are easily precipitate, adding of a small amount of a suitable electrolyte. They are not much hydrated. They are irreversible in nature. One precipitate cannot form the colloidal salt by simple addition of the dispersion medium. Their salts are usually formed the inorganic material like metal, their sulfide, etc. Their viscosity is almost the same as the medium. Their surface tension is nearly same as that the dispersion medium. Their particles that are not visible cannot be easily detected by ultra microscope. Their particles migrate in one only particular direction in the electric field. Multimolecular and micromolecular and associated collide. The main character of a colloidal is a particle size. When some solid substance is dispersed into a medium in which the solid substance is otherwise insoluble, such that after dispersion the size of the solid particle lie in the colloidal range, the system is called a colloidal dispersion. Example of colloidal dispersion are a gold sol and a colloidal dispersion of a S2 S3 in water, etc. Depending upon how the different substance may have size in the range of colloidal, the various type of colloidal or colloidal dispersion may be divided into the following three categories. Multimolecular colloidal, when one dissolution a large number of atoms or smaller molecules of substance with diameter less than 1 nanometer aggregate together to form species have size in a colloidal range. The species thus formed are called multimolecular colloid. The dispersed phase in the type of colloidal system may containing large aggregate of atom of or molecules form as a result of aggregating property of the dispersion particle. For example, a gold salt, many containing particle of a various size have several atoms. Sulfur salt consists of particle containing a thousand of acid sulfur molecule. They are held together by wonderful force of macromolecule collide. When a certain substance, big size molecule called micromolecule, has large molecular mass are dissolved in a suitable liquid, they form a solution in which the mm, of substance the dispersed particle have size in a colloidal range. Such substances are called macromolecule collider. These macromolecule substances are usually polymer which very high molecular mass. Example of naturally occurring macromolecule or starch, cellulose, protein, enzyme, gelatin. Example of man-made macro polyethylene, nylon, polyester, synthesizer, etc. As the molecule have large size, have dimension comparable to those of colloidal particle, their dispersion are called macromolecular collide. Their colloidal solution are quite stable and resemble true solution in many respects. Associated collide इनको micelles भी कहते हैं. The substance which when we dissolve in a medium at a low concentration behave as a normal strong electrolyte but at higher concentration exhibit colloidal state property due to formation of aggregate or associate colloidal. They aggregate particles which are called micelles. The formation of micelle take place only above a particular temperature. Craft temperature and above a particular concentration are called crystallization micelle concentration. The most example of colloidal is that surface which against a soft and determination force of crystallization micelles concentration 10 raised to power minus 4 minus 10 raised to power minus 3 mole liter. Each micelle contain at least 100 molecules. Thank you.